Let's look at an application example using law of cosines. So in this example, we are told that authorities are searching for a missing person, and they're using two cell phone towers to triangulate to locate the person's cell phone. And we have two towers. Tower B, we're told, is 50 miles due east of Tower A, and the cell phone has been detected somewhere to the north of the towers. Okay, so just from that information, we might have a horizontal line. Okay, that's the due east-west line. Right, so east is to the right. If you remember our cardinal directions, right? North, south, east to the right, west to the left. Okay, so we know that Tower B is 50 miles due east of A. So there's A, there's B, B is east, and this distance here is 50 miles. Okay, and we also know that the cell phone is somewhere to the north, right? So it's not below, it's above in our picture here. And we're told that the estimated distance to the cell phone from the two towers. So from Tower A, we know it's 35 miles, and from Tower B, we know it's 25. Now, since both of those measurements are less than 50, I know that the cell phone has to be somewhere here in between the two towers. If one of them was greater than 50, then the cell phone would be, it would kind of create an obtuse looking triangle. But because both of those measurements are less than 50, I know that it has to be in the middle. Okay. So we know the distance from Tower A is 35 miles, and from Tower B, it's 25 miles. Okay. And what we want to find out is what is the bearing. So bearing is just a fancy word for angle, and it is specific. We'll get to that here in a minute. What is the bearing that authorities should take from Tower A to get to the cell phone? Okay. So we're trying to find angle A. Okay, that's what we're looking for. So we're trying to find angle A. If we look at this particular problem, we are given all three sides. So again, just to verify, we are looking at a side problem. Okay, so that's law of cosines. And we want to find angle A, so we're going to use the law of cosine equation. A squared is equal to B squared plus C squared minus 2BC times the cosine of A. All right, we're going to plug our values into this and solve for angle A. So we plug our sides in there. So we're going to have 25 squared is equal to 35 squared plus 50 squared minus 2 times 35 times 50. And all that's times the cosine of A. Now, I could go ahead and do the algebra like we did in the previous one, but just so I'm not dealing with bigger numbers, I'm not going to multiply or square things out. I'm just going to leave everything as it is. Okay. To solve for A, I need to move the 35 squared and the 50 squared to the other side. So we're going to subtract those. So that means we're going to have 25 squared minus 35 squared minus 50 squared. And that's still going to equal the negative 2 times the 35 times the 50 times the cosine of A. The next step, to get A by itself, I need to divide everything that's being multiplied by the cosine. So the negative 2, 35, and 50 is going to get divided over. So on the left side, we're going to have 25 squared minus 35 squared minus 50 squared all over a negative 2 times a 35 and times a 50, and this is equal to the cosine of A. To get A by itself, we have to take the inverse cosine, and then we're going to do that on both sides. So A is going to equal the inverse cosine of 25 squared minus 35 squared minus 50 squared. And all of that is divided by negative 2 times 35 times 50. Okay, and you can actually just type that whole big expression into your calculator and it will give you the answer. And if we do that, we should end up getting that angle A is equal to 27.66 degrees. Okay, so in our question again, we wanted to know what is the bearing that the authorities should take from Tower A to find the cell phone. Okay, so we could say that it's 27.66 degrees. Okay, that is the actual angle in here, 27.66 degrees. Okay. Usually when we talk about bearings, though, we want to describe them using our cardinal directions. So we want to talk about them in terms of north and east, or south and west, or northwest, southeast, right? We want to talk about them in that kind of context. If we used that 27.66 degrees, that is a measurement from the horizontal line that we are rotating upwards. So that's a measurement from the east rotating upwards. So if I wanted to write that as a cardinal direction, I could write that as east 27.66 degrees north. So that means I'm starting facing the eastern direction and I'm going to angle upwards, or angle to the north, 27.66 degrees. Okay. The other way that we could write this is if we use north as our starting point. So if we think of out here is north, going straight, from point A vertically, perpendicularly upwards, what is this angle that we're going to turn east? Well, the two of those angles are complementary. So 90 minus 27.66 is going to be equal to 62.34 degrees. So instead of writing this as an east angle to the north, we could say this is a bearing of north 62.34 degrees east. Okay. Usually we like to reference ourselves off of north or south first. We don't have to, but usually we like to do that this way. Sometimes you just have to look at the context of a problem as you're doing this. But for now, let's say that the bearing, or sometimes you may hear it said as a heading. So the bearing or the heading is north 62.34 degrees east.